Okay, so this week we've already discussed how to solve various kinds of multi-step equations, um, whether they have variables on both sides or they do not. So remember your steps. Step number 1, distribute if necessary. 2 is to combine like terms. Step number 3 would be to, if we do have variables on both sides, get the variables on the same side. And the last step is just to solve. But today we're going to look at some special equations that have some special solutions. So take your notes out, follow along with us or with me as we're doing this, and make sure you're writing everything down. Please pause the video as needed to try to do as many of these on your own before you watch me do them. So here we have two equations, and I want you to take a look at the one that says no solution first. So let's go ahead and solve this and see what happens when we solve this. So just disregard the fact that it says no solution, and let's just solve this as if we were just solving any multi-step equation. So our first step would be to distribute. So we can distribute. We distribute the -4 to the 2x and to the 1, and that's normal. That's what we've been doing all week. So that would just be -8x minus 4 equals -8x minus 2. Again, we've been doing that. We've been doing that for a while. So what would we do next? Well, we don't have any like terms to combine on either side of the equal sign. So what we would do now is we would move one of the variables to the other side. We want to get the variables to the same side. So take a look at what happens when we do this, though. We would add 8x, right? And that would cancel this out. But when we add 8x on the other side, right here, that'll also cancel that out. That'll turn that into 0. So we're left with no variable. We're just left with two constants. We're left with -4 and -2. Okay, so you're going to have some situations that are like this. So what would your solution be in this case? Well, and we'll go more in depth into this tomorrow or Monday. But all you would need to do is you would need to see, hey, is -4 actually equal to -2? And it's not. -4 is not equal to -2. So when you do get an equation where the variables cancel out, where you're left with just two constants, all you need to see is whether the two constants are actually equal to each other. If they are not equal to each other, we'd say that this equation has no solution. There is no possible value that we could plug in for x that would make these two sides equal. And that's what I mean by no solution. Now let's take a look at the next equation. That's going to give us a bit of a different answer, and I want you to try to solve that equation on your own before I solve it, so that you can see what's happening here. So hopefully you had a chance to try and solve this. So here, once again, we would distribute first, just like we normally would, and this would be -5 minus 9x equals 3 minus 9x minus 8. Then we combine like terms, so that would be -5 minus 9x equals -5 minus 9x. And then we've distributed, we've combined like terms, now we move the variables to the same side. We move one of the variables to the other side. So if we add 9x here, just like our last example, both sides cancel out. So we're just left with two constants. But this is a bit different than our last example because -5 is actually equal to -5. So if all of your variables cancel out, you're left with two constants that are equal to each other. We say that there are an infinite amount of solutions. Okay, there are an infinite amount of solutions. That means you could plug in any value for x, no matter what value you choose, and this side will always be equal to this side. You could choose any real number, and no matter what number you choose, the two sides will be equal. Okay, and you could go ahead and try it out with some random numbers. If you put in 1 in there, both sides will be equal. If you put in -7, both sides will be equal. So with these kinds of situations, when both constants are actually equal to each other, then we say that we have an infinite amount of solutions. Let's do some more examples and see if we can understand this a bit more. So, go ahead and try and solve these on your own. See what you get. Hopefully you get it before I do. Pause the video, and then when you're ready, unpause the video and see if your answer matches mine. So for number 1, again, we're going to start with a distributive property. And this is just what we've already done this week. So that would just be 6x plus 6 minus 3x equals 6 plus 3x. Then after distribute, your next step is always to combine like terms. And we do have some like terms on the left-hand side of our equation. So that would just be 3x plus 6 equals 6 plus 3x. We subtract 3x on both sides, right? Our third step is to get the variables on the same side if we have variable on both sides, the same variable on both sides. So those would cancel out on both sides. So we'd just be left with 2 constants. Now, does 6 actually equal 6? Yes, it does. So with this kind of problem, with this kind of equation, we'd say that we'd have an infinite amount of solutions. No matter what number you choose for x, this equation would be true. The left-hand side would be equal to the right-hand side. Let's take a look at number 2. So again, distribute first. We get 12x minus 36 equals 14x minus 28. Okay? And then we would go ahead and combine any like terms we might have, which we don't have any like terms. So what we would do next is get the variables on the same side. Well, the same variable on the same side. So we subtract 12x. You could also move the other one if you wish. And that would leave you with negative 36 equals 2x minus 28. Now this is just a regular 2-step equation. We add 28 on both sides. And we would get negative 8 equals 2x. Divide by 2 on both sides. And we get our answer, which is x equals negative 4. So with this example, we actually got a solution for x. It wasn't one of our special circumstances where we get either a no solution or infinite amount of solutions. We got an actual solution. There's one answer that would be correct, which would be negative 4. Let's move on to number 3. And I hope you got negative 4 before I did. Hopefully you tried this out before I did. And I hope you got negative 4 before me. And so number 3, once again, we start with a distributive property. And again, please make sure you're pausing these and trying to do these on your own before you watch me do it. So 8 times 5 would be 40x. And then 8 times negative 3 would be minus 24, negative 24. And that would equal negative 18x minus 24. 6 times negative 4 would be a negative 24. So, we distributed. We don't have any like terms to combine, so now we would just get our variable on the same side here. We'd add 18x on both sides. We'd be left with 58x minus 24 equals negative 24. Then we just add 24 on both sides, and if you notice here, this is going to be 0. And that's also going to cancel out. But that doesn't matter. I mean, we still have a variable. We still have 58x. It's not like our previous examples where the variable is canceled out and where we had just constants left over. We still have a variable. So we would still solve this the same way that we solve any other type of equation, any other equation that we've had in the past. We just do inverse operations. Even though we have a 0 on the right-hand side, we would still need to divide by 58 on both sides. And then obviously our answer is just going to be 0 divided by 58 is 0. So x is going to equal 0. But there is a solution, just one solution for this problem, and it's 0. The only time that we're not going to have any solutions, or that we're going to have an infinite amount of solutions, is if our variables were to cancel out, and we had no variables left. We'd just be left with constants, which we're going to see again in number 4. So let's take a look at number 4 now. Try to do out number 4 on your own before I do, and then we'll compare our answers. So number 4, nothing to do on the left-hand side of the equation, but on the right-hand side of the equal sign, we do need to distribute. Okay, so we're left with 3x minus 13 equals 7x plus 14 minus 4x plus 28. Okay, now we need to combine like terms. So we have 7x negative 4x, and we have 14 and 28. So (7x minus 4x would be 3x, and 14 plus 28 would be 32. I'm sorry, I meant 42. It would be 42. Okay, then what would we do next? Get the variables on the same side. And if we do that, you would see that the both sides, we'd have the variables canceling out. So we'd be left with no variables. We'd just be left with two constants. We have negative 13 equals 42, which negative 13 does not equal 42. So this would be an example where we would have no answer, no solution. There's no possible x value that would work for this equation. So go ahead and practice these. You're going to get a worksheet now to do. Practice them. Watch this video again if you need to watch it. So remember, if you're left with two constants, if they're equal to each other, then there's an infinite amount of solutions. If they are not equal to each other, then there are no solutions. All right. I hope to be back tomorrow. I apologize for having to miss it the last couple of days, but hopefully I'll be back tomorrow. Be ready for your test tomorrow. Your test would be on everything we covered this week, including this video. So you'd have solving multi-step equations, and that includes solving multi-step equations that might have no solutions or an infinite amount of solutions. So make sure you look over all of your notes and be prepared for tomorrow. I want to see a lot of great grades tomorrow. You guys have been doing excellent this week, and I really hope to see you all tomorrow. Goodbye.